So, stratified sampling. This is the most common type of question for sampling that you get, is about the stratified ones. So what is stratified sampling? Well, strata, which is where the stratified comes from, means layers. You can often come across this in geography when you're studying rock formation or something like that. You get stratas of different types. So basically what we're going to do is we're still going to use typically random sampling to actually pick, but we're going to group the population and pick from those groups. So we do use stratified sampling only when we have unequal groups in the population. If all the different types or categories in the population are about equal in number, there's no point doing stratified sampling. But if you've got a setup, a bit like a school, where you want to sample from the whole school, so that you want to include teachers as well as students, clearly there are vastly more students than there are teachers. So if you did normal sampling, there's a good chance that you might not actually pick any teachers for your sampling, and so you wouldn't get a proper balanced view of whatever the question is that you have. So what we would do is split the school into a group of teachers and a group of students, and then you would take the same proportion, the same percentage of teachers as you do take of the students. So you still have fewer teachers in your sample than you do of the students, because that reflects the balance of numbers. But this way ensures that you do have somebody from each group in your sample. So with that said, the key thing that you have to do is work out what fraction, decimal or percentage, all the same thing really, what fraction the sample is of the population, and then you're going to take that fraction of each of the groups that you've identified. And just a little warning, hopefully I'll remember to mention it as we go along, there is a potential for rounding errors sometimes when we're doing this process. So let's look at an example. So here we have an example. This one is based on 180 employees in a school. Okay, it tells us that there are 94 teachers, 16 teaching assistants, 41 admin, and other 29. Okay. And then it asks us to work out a stratified sample of size 50. And we've got to work out how many we would need from each group in order to do a correct sample. So we're going to find that fraction to start with. So the sample size is 50 and the population size is 180. So I think you can see here that we want 5/18 of each category. So now with the aid of a calculator here, all right, so we want 5/18 times the 94 for the teachers, first of all. And that, if I change that, gives me 26.1. Now you can't, sorry, you clearly can't have 0.1 of a teacher, so we're going to put 26 down for the time being. Okay, so let's go back and change, whoops, and change that number. So it's always going to be 5/18, but now we're doing the teaching assistants, which is 16. So we'll put in 16 there instead. Let's change that. So this time it says 4.4, so I'm going to say 4 teaching assistants. So let's go back. Admin was 41, so we'll put that in. And that gives us 11.38 recurring, so I'll put 11 down there. Okay. And then back we go and change that to 29 for the other. That gives us 8.05. Now, What we must now do is check that we've actually got 50. So we've got 26 plus 4 plus 11 plus 8, and that equals 49. So this is what I mean by a rounding error. So we rounded down a lot of times, and that's why we're 1 under. So how do we fix that? We've got to add 1 to one of these categories that we've got here. Now what you do is you always adjust the one that's got the biggest number in it. And the reason why you do the biggest number is because it will have the least impact. It won't make a significant change. In other words, 1 out of 26 is a much smaller amount than 1 out of 4, for example. Yes? So we're going to change the teachers to 27 so that we've got our full 50. Okay. At the bottom it goes on to describe a method how to obtain the actual stratified sample. So to do that you could use random sampling within each group to get the right numbers. Let's look at another 1 or 2 examples here. So the top here we've got rugby referees. We've got Ireland with 8, Wales with 28 and Scotland with 44. So we've got different categories, different countries in this case, and they're not very even, so that's why we're doing stratified. It says that he wants to take a sample size of 10. So first thing we've got to do is work out how many we've got altogether here. So we have 8 plus 28 plus 44, which equals 80. So what fraction are we going to take? So we want 10, our sample size, divided by 80, the population size. So that means we want 1/8 of each of these numbers. Now, 1/8 of 8 for Ireland is too easy to even bother with the calculator. So 1/8 of 8 is 1. But we can use the calculator for the others. So 28 divided by 8 is going to give us 3.5. So for the time being, I'm going to call that 4. And then we want 44 divided by 8, and that gives us 5.5. So I'm going to call that 6 for the minute. Now if we look, we wanted a sample size of 10. If I add these up, I think you can see that I've got 11. So what am I going to adjust? I'm going to adjust the biggest one here. So that is going to become a 5 instead of a 6, and now it fits. Another example here. This is 300 students in years 7, 8, 9 and 10. And we can see for some reason, a bit more unusual this, the year 8 seems to have a lot more than the other years. So we want a stratified sample of 50. Okay, so then 50 divided by 300 is going to eventually get us to 1/6. So we want 1/6 of each of these groups. So that means we're just basically going to divide everything by 6. So 72 divided by 6 is going to give us 12 for year 7. Then 108 divided by 6 is going to give us 18 for year 8. 66 divided by 6 is easy, that's 11 for year 9. And 54 divided by 6 is 9. Now, because we didn't do any rounding here, I don't really need to check the adding up there, but sometimes it can be worth it. So 12 and 18 is 30, and 11 is 41, and 9 makes 50. Okay, so we're just going to look at one more here. Sorry. Okay, so this is about inhabitants in a village and their age. So we've got all the different categories here and how many we've got, and he wants to take a stratified sample, and it's first asked us to explain why that's appropriate, and it's appropriate because they are different numbers. We've got roughly 700, 1200, 800, 400, so there are different sizes of the categories. They don't have to be precisely the same, but if there is that difference, then we need to take stratified. Now it says we're going to do a stratified sample of 100. So in this case, I now need to work out how many people there were altogether. So 693 plus 1203 plus 802 plus 405 gives me a total of 3,103. So we want the fraction 100 over 3,103. Now that's not going to turn into a nice fraction. So in this case, what we might opt to do instead is turn that into a decimal. So it's 100 divided by 3,103, and that equals this decimal. So now we're going to take and use that decimal, 0.03222 something or other, for each of the groups. So we're going to take that and we're going to do multiplied by 693 for our first category, the 0 to 20 category, and that gives us 22.333. So we'll go 22 for the time being. So let's go back and change the number there. So the next one is 1,203. Whoops. Right, we're going to have to start from scratch there because it's multiplied by, it hasn't done what I wanted it to do, unfortunately. Okay, so 100 divided by 3,103 times by 1,203 equals 38.7, so we'll make that 39. Okay, right, so this time I should probably be able to get away with this, so let's try the different number. So we've got 802, that's 28.5, so we'll make that 26, and then back again and change that to 405 for the last one, and that's 13.0, so I'll make that 13. So now let's add these up and see if we've got 100. So we've got 22 plus 39 plus 26 plus 13, and that does actually equal 100, so we don't need to adjust anything. So that's stratified sampling.